So we're going to capture the type of the items in that array as value type in a generic, and then we can reuse that in that callback function definition. So we can say that that callback needs to take a type of the same, and then also in the return, meaning that the return has to be an array of value type. And now this my filter function is completely type safe from tip to tail. Last week I did a video on React 18's new useExternalStore hook, and I got a lot of great feedback, so thank you for that. And a lot of it was, why didn't you use TypeScript? Which is kind of a logical choice because we were doing a lot of state management stuff. And I love TypeScript. I've actually done a whole series on TypeScript. So, okay, well, here's where we are. So what we're going to do is, now we're going to do it in TypeScript, and we're also going to learn a lot about generics along the way. So let's jump right into it. So if you didn't check out last week's video, let me catch you up a little bit on what we had done. So useExternalStore is about managing the connection between an external store, think like Redux or MobX or something like that, and your React application. So that when the external store changes, the React app automatically goes and sees those changes. And now the nice thing is that you can go and add your own store to that mix. And that's exactly what we did. We created our own custom store and used that sync external store hook to connect it to our React app. And we did it in two different ways. We did it in a client-side rendered app using Vite, and we did it in a server-side rendered app using Next.js. And the reason we did that was because synchronizing external state stores between CSR applications and SSR applications is just slightly different. It's a little bit more complex on the server-side rendered side. So in this video, what I'm going to do is we're going to take that server-side rendered example, and we're going to go and convert that to TypeScript because I think that's actually the slightly more complex one. So let's go take a look at the code. We have our two examples up here. This, of course, is in GitHub for you for free. We have the CSR example, or client-side rendered, and the SSR example, which is that Next.js example in the SSR directory. So what I'm going to do is I'm just going to do a copy-r here for cursive, then SSR, and I'm going to create a new directory called SSR_TS for TypeScript. That was pretty quick. So let's jump in there, SSR_TS, and then do our yarn to install our node modules, and then yarn dev to bring it up in our browser. So here's our application. On startup, it starts with a value 1 at 12 and a value 2 at 14. You increment either of these and they increment independently. And the usual kind of counter state manager example. So let's go into the inspector and just make sure that we're doing this well. And to do that, we can go over to our components section and bring up the gear and make sure that highlight updates when components render is on. And that will tell us if we click on increment value 1, is the only thing that renders value 1, because that's important. So if I do that, then yes. So we're getting good isolation between the update of the store, which has both of those values, and the React app, which can say specifically, I want value 1 only through the use of a selector, so that when I increment value 1, the only thing that updates is that value 1 value, even though there's two values in the store. Okay, let's go take a look over at the implementation of this. If I head on over to SSR_TS, and I've got a source for the store. And again, this is all in JS. Sorry about that. And we have the index page, which has the page with the buttons on it, the increment value and display value buttons on them. So our store is pretty simple. We have a function. It creates a store, takes an initial state, which in this case is an object that has value 1 and value 2 in it. They are initialized to 0, which is interesting because if we look back over here and we refresh, you can see that they start on the server at 12 and 14. So let's keep an eye on that as we go forward. Then create store returns this object. That object has get state, which unsurprisingly returns the state, set state, which unsurprisingly sets a new state, but also alerts any subscribers that the state has changed. And the way that it does that is that the subscribers will have called this subscribe method, which returns an unsubscribe, and added themselves to the listeners. And now every time we do a set state, we alert every listener by calling that callback that we were given. And then finally, we have a server initialize method, which is specific to server-side rendered apps, in our case, this Next.js app. So let's go take a look over at index.js, see what's up. So we bring in the store, and then on the server side, we use this get server-side props. That's a Next.js function. It returns the properties that we should pass to the page component on startup. So in this case, we're going to pass the initial state of value 1 and value 2 are 12 and 14, which is why we get the difference here. If we let the default values go, those would be 0 and 0. We just want to test to make sure that we can set new values in the store here. So we can. So this initial state is defined as a prop. Therefore, it comes in as properties to our app here, initial store. We then call that server initialize method that we created over on that store. We also go and put that initial state in a provider. You'll see why we do that in a second. And then we render out our components. So we have two components here. We have increment value and display value. So let's look at increment value first. Increment value is the button. So it's got the button in there. And then on the click, it goes and asks the store for its state. And then once it gets that state, it then sets that state by saying, okay, give me everything in the original state, but override the item key and give it that value plus 1. So what is this item thing about? Well, if you look down here, item is value 1 or value 2, which not unsurprisingly are the keys in our create store. Cool. So the next thing we do is we then display those values. And for that, we use this useStore custom hook. And that was really where the fun came in for that particular video, because useStore has to subscribe to the store so that it gets notified when that store changes, because React doesn't know anything about that external store, right? So the way that we do that is we use this new React 18 hook called useExternalStore. And it takes 3 arguments. It takes a subscribe function, which we pass our store.subscribe. useExternalStore then calls that, gives it a listener that it knows about, and then subscribes to that store. And then when the store updates, that listener that useExternalStore created fires. It then calls this get snapshot function. And that get snapshot function then returns the updated state. Now, in our case, we're running that through a selector. And that selector is then picking off just that one value. So in this case, this display value is picking off that value 1 or value 2. And that's why we get that isolation when we do the updates, so that the value 1 display only updates when the value 1 changes because of that selector. And then this third function here is specific to server-side rendered applications, in this case, Next.js. And it gives you the state at server-side render time. So it's the server-side snapshot. So a bunch of folks asked, practically, why are we learning this at all? Can we replace Redux with this? And that's an interesting question for 2 reasons. Well, first, I think we're learning it because, in my opinion, it's good to understand how the external store connects with your React app. A lot of applications have external stores. And so understanding how that mechanism works will help you better understand your React applications, and in particular, why you want something like selectors for efficiency's sake. The other thing is, a lot of folks are interested in replacing Redux, so maybe that's a good conversation for another video. But back into it. Okay, so we have our useStore over here, and we use that in our display value. We get the state, and then we pull off the item that we want using that selector. So let's convert this to TypeScript. And when I convert something to TypeScript, I like to keep in mind what my ideal end state is, because I think with TypeScript, you can kind of go a little bananas with all of the utility types and all of the generics and things like that. So I just want to keep in mind what the goal is here. So the goal, I think, for me is, 1, to make sure that the entire app is type safe. So we have types for everything. And that this create store is reusable, meaning that if we want to have multiple stores, multiple sets of these, like let's say we had some user data and then we had some cart data or whatever, and for some reason we want to keep them in separate stores, we could do that in a type safe way. So we want everything to be type safe and create store to be reusable. Those are 2 things that we're trying to do. And all of this starts with changing the store.js to store.ts to make it a TypeScript file, and then index.js to index.tsx. Okay, so now we need to rerun the server to get it to acknowledge that there are changes in the file names. And we'll do yarn dev again. And now it's going to freak out because that's next telling us, hey, it looks like you're using TypeScript. I love these errors. These are great. So we need to add some dependencies, and in particular, TypeScript, which would help a lot. And then the types for React and the types for Node. So let's copy that and then paste that in there. And now we'll do yarn dev again to bring up the server. And that will work, but it'll also create this tsconfig.json file, which is our TypeScript configuration. And let's see. So strict is set to false. And I don't think we want to do that. It's kind of loose typing. So I'm going to set strict to true to make sure that every single one of our functions has at least the parameters safely typed. So I'll set that to true, and we'll see what happens here. So we can see little red squigglies coming up already. So we got a bunch of red squigglies up here in index.ts, and we got a bunch of red squigglies over in our store. And I think the best way to go about this would be to start with the store. So we need to define what the initial state is. Well, the initial state is a value 1, value 2. So I'll just start off there saying that this is value 1, value 2, and we'll see that those are numbers. So far, so good. Now down here, we need new state, which is also value 1, value 2 is a number. Now I could just go and just keep on copying and pasting this all around, but I think the better thing to do would be to define a type. So I'm going to define that type as values store. How about that? And then I'll give it that value 1, value 2. And now we have a reusable type, which I can then use here and also here and down in here for the server initialize. Not a bad start. So now we need to type this listener. So a listener is a function. Define it as a function, and it doesn't return anything. That takes, in this case, the current state. So we'll give it an argument of the state, and that would be a value store. All right, so now what is it complaining about? Well, it's saying that listener is of type unknown. So listener is coming from listeners, which we're running for each on to go and get every listener. Listeners is a set, and that set, we don't give it any data. We didn't say 1, 2, 3 or something like that, which would tell us in that case that the listeners is a set of numbers. We just gave it nothing. So it doesn't have any way to infer what the type of that set is. So we need to use the generic syntax to define that type. So you use the less than greater than, and then you wrap the type. So in this case, that's the state. And now listeners is defined as a set of these functions. And everything actually looks pretty good. Okay, great. So let's head on over then to our index.ts. Now let's take a look around. So let's start from the bottom. Our app takes an initial state. That initial state is that value store. Now we could just copy and paste value store from there to here, but then if I update value store in one place and I don't update it in the other, we could get out of sync. Best thing to do is just share them. So let me do an export here of that value store, and then I can add it to the import right here. So I can say we want to bring in the type of value store. And then down here, I can specify that our initial state is a type of value store. So let's take a look over at display value and increment value, our two little components. Now they both take items, and an item in this case is the key of a value store. So our value store has two keys in it, right? Value 1, value 2, and our item has to be one of those two things. Now, if I were to get rid of that and then do option space here, it doesn't give us any hinting. I don't know what you're talking about. That could be anything. So let's see if we can do better. So I'll go over here and I'll look at item, and I'll say that the item is a key of value store, meaning it has to be one of the keys in value store. And the same sort of thing up here for display value. Now, if I come down here and I do the same thing, and I hit command space, Now it hints us. It tells you, hey, it has to be either value 1 or value 2. If I put in there value 3, it's not going to be happy. If I put in there just an empty string, not going to be happy. But if I put in value 2, that's happy. How cool is that? So we're getting increasingly type safe as we go. Okay, so let's get over to our useStore selector here. Now I noticed one thing about this. One thing is that we don't ever send an empty selector. So let's just get rid of this default here. And then let's start typing this. So a selector is going to be a function. It's going to, in this case, return a number. And it's going to take as input the state. So that would be the value state. Cool. So far, so good. And that leaves us with the context stuff. So there's a couple of things about this. First off, people noted rightfully that I actually have a React no-no here, which is I'm calling use context within a callback, which you shouldn't do. I completely agree. Nice thing is we can actually get rid of all of this context stuff because really down here in our server initialize, we get the state. And instead of using a provider to pass it around, we could just hold a copy of that in the store. So let's go do that. Let's kind of take this context stuff out. So on server initialize, we get an initial state, which, you know what, I should call initial server state just to be a little bit less silly. And it is of type value store. And then we look to see if we're already initialized, and if we aren't, then we set the current state, which is a good idea, and then we set this to true. So you know what we can do? We can reuse, essentially this is initialized, but instead of using it as a Boolean, we can use it as a place to put that server state. So let's do server state instead, and say that it's going to be either a value store or null. And we'll start it off at null. We'll say if we don't have a server state, then set the current state. Otherwise, set that server state to that incoming initial server state. Nice. And now down here, we can say get server state. And that's just going to return that server state that we stored off. And we can go back to our index.ts and scroll up to our useStore and say here, store.getServerState instead. Nice. Except in this case, we're saying, well, it could be null because we've initialized it to null over here. And we may or may not have set the server initialize. So we need to ensure that getServerState returns something, even if we haven't already set it. I think the best thing to do there would be to use the null coalescing operator, which basically says if server state is not null or undefined, then use it. Otherwise, use whatever on the right-hand side of this expression, which will just start off, I guess, with initial state. Probably be a better thing to do. And now, if I look at the type definition of getServerState, now it returns always a value store. So that's awesome. Let's go take a look over here, and we're happy. That's good. And now we can just get rid of the context stuff. Let's get rid of that, and get rid of this, and get rid of that, and get rid of our imports. I guess the question is like, how did I get there? And I started with the context, and then I added the server initialized stuff later. And I guess at that point, I probably should have removed the context stuff. Just kind of forgot about it. All right, let's see if it works. Let's jump on over here, and that's kind of interesting. Okay. Oh, did I like reset? Oh, yeah, I did. Okay, there's value 1. All right. Yes, looks like it's working. Awesome. Okay. All right, looks good. So we now have a completely type-safe application from tip to tail. And the next thing we want to do is we want to make this create store reusable, meaning that we can have multiple different stores with different shapes simultaneously. And right now, it's really locked into a value store. So you can make multiple stores, but they're all going to be value stores, which is not what we want. And one of the things that's going to hold us back from doing that is that useStore down here is kind of hard bound to that value store. So if we create a new store, we'd have to create a new useStore specific to that store, which I'm not really a fan of. And I don't like the fact that useExternalStore is over here kind of in the client-y part of the code. I think we should move useStore over into the store so that when you create a store, you get a new hook, and that hook is specifically type safe to that store. So let's go and cut this out of here and paste it into store, and then do some modification to make it work. So we'll put that up there, and yeah, do that. Okay, looks good so far. So use sync external store. We need that, so we need to import it from React. And now let's take a look. So get state, we actually have it. We're inside the closure of create store. So I can just use current state there. And get server state, well, we just got that. So that's server state. Pretty cool. Or initial state. Okay, now we need to deal with subscribe. I think we want to keep subscribe externally visible as part of the API surface of the create store. So I'm just going to define it up here and then just share it out. So I'm just going to copy this and then do const subscribe. There we go. Easy peasy. And now I can just return subscribe, but I can also just use subscribe down here. All right, let's see if this still works. Well, it doesn't because this is red and that's telling us that useStore isn't defined. Fair enough. So useStore is now coming out of the store. So we can see that the API of store is get state, set state, subscribe, server initialize, get server state, and useStore. So the easiest way to get to it, just go over here and just say store.useStore. Ta-da! And now we can get rid of our import and we'll refresh. And it works. Awesome. So now we have a type-safe useStore coming out of our create store. That being said, useStore is expecting that every selector is going to return a number. And I don't think that that's particularly reusable, right? That means that this is reusable, except that every single key in this store needs to be selectable as a number. You can't put strings in there or Booleans or anything else, that's not reusable. So what we need to do is make useStore more generic because we know that selector outputs something. And we want the entire expression of useStore to output that. So if selector is returning a string, then useStore should return a string. If selector is returning an array, then useStore should specify that it's returning an array of a particular type. The best way to get that done is to get into generics, which I think a lot of people kind of freak out about. So let's go and take a little field trip and see if I can make them a little bit easier for you. So let's do some examples. Our first example is this add unique ID function. Add unique ID takes a name, which is a string, and it takes some extra data, which is really up to the caller to define. And then it returns an object. That object has an ID that it generates from add unique ID. And then it's got the name and it's got that extra data in it. Now, because we've defined extra as unknown, it's going to take any type coming in there, whether it's a string, a number, array, whatever, and it's going to lose that typing information because we're essentially downcasting it to unknown. And so coming out of this function, that extra is going to be unknown. You probably don't want that, right? You want to retain that type going through. So what we can do instead is we can define that extra isn't extra type. And we can say that that is a generic by using the generic syntax at the beginning of that function. We can use the less than and greater than to wrap extra type. And now we can reuse that. We can reuse that inside the body of the function, or we can reuse that in the return type. So we can just change that unknown for extra to extra type. And now if I were to invoke this with, say, Jack 25, that extra type would be defined as a number, and the return type would be defined as a number. If I were to say that this is an object, then it would take the object type and say that that's what the return type now is. And so our typing is retained all the way through that call system. So that's pretty cool. Okay, so far so good. Well, let's try one that may be a little more complex. So this is a myFilter function. It takes an array of numbers and a callback function that takes a number as its input. And that callback function is called back with every single item in that array. And when it returns true, then that number becomes part of the output array of this myFilter. It's basically just array.filter. So this myFilter really doesn't have anything to do with arrays of numbers. It takes an array of something and a callback that takes a something and gives you back a Boolean, and it operates on that. So we could make this function more generic and more reusable, but still type safe using generics. So what we can do instead is say that the array is a value type array. So we're going to capture the type of the items in that array as value type in a generic, and then we can reuse that in that callback function definition. So we can say that that callback needs to take a type of the same, and then also in the return, meaning that the return has to be an array of value type. And now this myFilter function is completely type safe from tip to tail. All right, pretty good so far. So let's go take a look at our useStore and see how we can do that. Well, in this case, what we're really interested in is the output of the selector. So we'll call that the selector output, and it'll make that generic. And now we can make the entire function return a selector output type. And that ensures that whatever the selector is outputting, useStore then outputs that as that type, and the entire system is type safe from tip to tail. Awesome. Now you might see a lot of folks doing names like T when it comes to generic, probably for type. That's really just an option. You can name these generic types whatever you want. And I think like a variable, you should name them like a variable name, something that's meaningful as opposed to just T. Because if you have multiple generic types within your application or within your function or whatever, it's going to get hard to track just visually. So I think having them more symbolically named is better. So I'm just going to go with selector output. All right, let's go back into the code and check out how we do this. So we're going to go and change number in this case to selector output. We're going to make that generic. And then we're going to have the output of this function be a selector output. And now if we go down to here and we look at useStore, yes, we're outputting a number, but that's because the selector here that we have is peeling off a number. If I were to remove this, then useStore in that case would return the full value store. Or if I were to give it just a constant value like hello, then useStore would return a string, which is the type of hello. All right, so now our useStore is more generic and more reusable. But how about the whole store? So let's try that out. Let's go and build a completely generic create store. So I will go and copy that and then create a new file called createstore.ts. Paste that in there, and that's going to have our implementation for create store. And I will export that as the default. And really all we need to do is define that create store is going to take some shape. And we'll just say that that's a shape. And now anywhere we say value store, we are going to say shape instead. And now you can call create store with anything you want. Could be a number, could be a string, could be an object like we have. And it will go and build a store that is completely type safe for that state. So let's go back over here to our import and then import that. And we can just get rid of this implementation. All right, let's see if it still works. And it does. That's awesome. All right, so there you go. Now we have a reusable create store and our application is completely type safe. That being said, I think we can go a little bit farther. So we have kind of a duplication here because if you look at store.getState, the output of store.getState is that shape. So instead of defining it, we can just use a utility type to grab that type. And we do that using return type. And return type will give you the return type of anything that you pointed at. In this case, store is not a function. So that's why we're getting the red squiggly, but store.getState is. And if I look at value store, the output of that getState is the shape that we have defined up here. How nifty is that? I love those little utility types like that. So nice for not duplicating the typing information. All right, well, I hope this helps sate your interest in TypeScript in this particular example. If you have a better way to do it, be sure to put that in the comment section down below. I would love to hear it. In the meantime, of course, if you like the video, just hit that like button. If you really like the video, hit the subscribe button and click on that bell and you'll be notified the next time a new Blue Collar Coder comes out.